Hey everyone, so I'll be showing you how to use Auto Envelope. This is a generative design tool for the class 220C. So Auto Envelope is a design tool that aids architects and engineers in deciding what's the best exterior wall section for their project. So the inputs are the thickness of the wall, the R value, the cost, and the carbon emissions per square foot. Usually when architects make decisions, they use standard designs, just the standard wood studs and metal studs with the standard exterior insulation, and they achieve the right R value of, 11, 13, all the way to 20, whatever they need, and then just move on. Using this tool, you can, in the concept phase, you can find a better cost-effective and environmentally friendly solution. So going in the program, on Revit, you'll have your wall section as shown here. So that's all you need. You just need the wall section with the given layers. So you can go into Dynamo. So in Dynamo, the inputs are the material selection. So here's the cladding versus brick, plywood versus dense glass, metal stud or wood stud, things like that. And also the thicknesses of each of these layers as shown here. So all of these nodes and all they do is calculate the right outputs that you need. So it's the R value, the cost, the thickness, and the carbon emissions. So what we go ahead and do is create a study for this, and this has already been done. You usually just go and create a study and you run the generative design as you need. This has already been done, so I'll just show you what that comes out to be. So here's a generation that was done for 10 generations for the study that was done, and you can see here that the R values, the thickness, the cost, the carbon emissions, all that selections made here. Let's just say, for example, that you have a space constraint as an architect of about 15 inches. So we will make a constraint here in the thickness of the wall from 0 to 15 inches, and you can see all the results that are outputted from this generative design as shown. So what you can go ahead and do is go to a graph here. So the graph here shows the thickness on the x-axis versus the R value on the y-axis, and here you can just filter out up to 15 inches thickness of wall, and you can select what you need. So on here, I'm just going to select a random value. Here you have the R value, thickness, cost, and carbon emissions as shown. So red means it's better in terms of carbon emission, versus all the way to blue means it's the worst environmentally. So that's something you keep in mind. And the size of the data point of this scatter plot shows how expensive it is. So the smaller they are, the more cost effective they are. So as a designer, if I'm looking within 15 inches, I kind of want to be in the sweet spot here of all the red values, because that's with the least carbon emissions. So something I would select would be here. So this value has an R value of, let's say, about 23. The thickness of the wall is 14 and a quarter. Cost is about $7 per square foot, and the carbon emissions is 52 pounds per square foot, which is pretty good. Let's say you do need a higher R value than the 23. The next thing I would look at, okay, this one here is, it's even thinner. So I'll look at this, and it's R value of about 28. So 13 and a quarter. Cost is about $8.50. Problem here is the carbon emissions is almost twice. It's about 132 pounds. So if you're thinking about environmentally, this would be a bad solution, but in terms of the R value, it's pretty good. If you want to be more environmentally friendly than this, and with still a better R value, you'd look at something here. So the R value of 31, which is really good. Thickness is 14.75. Cost is about 10. Carbon emissions is about 81 now. Problem is now the cost has gone up about twice as much. So there's a clear trade-off here between whatever values you need. So just based on this and concept design, you can make the best decisions for yourself. So I'm going to go ahead and select this one here, which is very environmentally friendly and also cost effective. And I'm just going to open this in Dynamo. So I've done that now, and I can go back to my, let me just save this. I'll go back to my Revit. So this is just loading in all the values that were associated with that cost-effective and environmental friendly solution. And once this loads in Revit, you can select the wall section here, and you can see what was the solution that was needed from you. So it's a 4-inch aluminum cladding, 6-inch rigid insulation, 1/4-inch plywood, 6-inch stud, and 5/8 drywall. So that's the section that worked the best and is already inputted in Revit for you. What you can do is also go back into Dynamo Player. So I have that open here, and you can adjust the values as you need and play around. So I'm just going to change this to brick, leave everything else the same, and I'm going to go to a 4-inch stud instead, leave everything else the same, and I'm going to run this simulation. And again, you can get the same outputs that you need. So if you're just trying to play around and see what works best, you can always go into Dynamo Player, change some values up, and you get all the outputs you need. You can make the best decision for yourself as an engineer. Thank you.